In this video, we're talking about negative exponents and power rule. And remember that we've already talked about power rule, which tells us that when we have x raised to the power of a, so this a is an exponent, x to the a, and then we raise that whole thing to the power of b, we have a second exponent here, then that's the same thing as saying x to the a times b. We just multiply the two exponents together to create one new exponent on the base of x. This is a formula that we use called power rule to help us simplify exponent problems. So this is going to be power rule. What happens when we are dealing with negative exponents where either a and or b is negative? Well, let's do a quick review of just power rule in general. Here we've got an applied problem. We have x to the fifth and then raised to the power of 2. So x to the fifth is squared. Well, power rule just tells us that we can multiply those exponents together. So this actually becomes x to the 5 times 2. We multiply the exponents together. 5 times 2 is 10, so we get an answer of x to the 10. The reason that this works is because we're really saying we have x to the fifth, and then because we're squaring it, we have two factors of x to the fifth. So it's the same thing as x to the fifth times x to the fifth. We just have two factors of x to the fifth. And we know from studying exponent rules that when we have x to the a times x to the b, in other words, the bases are the same but the exponents are different and these are multiplied together, that this is equal to x to the a plus b. So when we have our bases separated like this, each with its own exponent, we add the exponents together. So we've transformed our power rule problem into a different kind of problem, and here we can say that this is x to the fifth times x to the fifth. This formula tells us that we add the exponents together and we get x to the 5 plus 5, which we know is x to the 10. So notice here that we did it two different ways, but each time we got to the same answer. We got x to the 10 both times, and that should always be the case. You should always be able to get to the same answer no matter which way you do it. If you multiply the exponents using power rule, or if you break the factors apart and then you add the exponents. So here let's do another example, this one with a negative exponent. So we have m raised to the negative 3, and then this whole thing raised to the power of 4. So this inner exponent here is negative, the outer exponent is positive. Using power rule, the fact that one of these exponents is negative doesn't make a difference. We just go ahead and multiply negative 3 by positive 4. Negative 3 times positive 4 is negative 12, and we get m to the negative 12. So it's no different than when we have two positive exponents. Using power rule, we can just multiply the exponents together and we can get our answer. Alternatively, we could do it a different way. We could say m to the negative 3 we know is the same thing as 1 over m to the positive 3, and we could raise that whole thing to the fourth power. So we haven't changed anything, we've just rewritten m to the negative 3 as 1 over m to the positive 3. Those two things are the same thing. We could also approach this problem the way we did here, where we said we had four factors of m to the negative 3. So we could rewrite this as m to the negative 3 times n to the negative 3 times m to the negative 3 times m to the negative 3. In other words, 1, 2, 3, 4 factors all multiplied together of m to the negative 3. That's what m to the negative 3 raised to the fourth tells us, that we have four factors of whatever's inside our parentheses here. And then we've turned it into a problem where we use this formula and we add the exponents together. So we say m to the negative 3 plus negative 3 plus negative 3 plus negative 3. So we say m to the negative 3 plus negative 3, which is negative 6, plus negative 3 is negative 9, plus negative 3 is negative 12, and we get m to the negative 12, which is the same answer we got when we used power rule. So either way that you do it, as long as you do the math correctly, you're going to get to the same answer. It works either way. Let's do another example here. This time the inner exponent is positive, the outer exponent is negative. We can do this problem using power rule where we multiply the exponents together, and we're going to get y to the k times negative 3. We multiply k times negative 3. We get negative 3k, so our answer is y to the negative 3k. We can also do it this way. We know that y to the k raised to the negative 3 power is the same as 1 over y to the k raised to the positive 3. In other words, we change the sign on the exponent from negative 3 to positive 3 just by moving this whole thing from the numerator to the denominator. Now that's positive, and we can say that we have three factors of y to the k. So what we get is 1 over y to the k times y to the k times y to the k, 3 factors of y to the k multiplied together, and now we have this problem up here where we add the exponents. So k plus k plus k is 3k, so we get 1 over y to the 3k. Instead of leaving this as a fraction, if we want to get rid of the fraction, we can take this value y to the 3k out of the denominator, move it back to the numerator, and we get y to the negative 3k. In other words, we can move it from the denominator to the numerator just by changing the sign on the exponent. Right now we have a positive 3k, so we change the sign to a negative 3k, and notice here that we got the same answer, y to the negative 3k, as we did using power rule. So either way it's going to work. Let's do one final example here. We have x to the negative 4 raised to the negative 2 again. We can use power rule and just multiply the exponents. Negative 4 times a negative 2 is a positive 8. The negatives cancel, and we just get positive 8. So we get x to the positive 8 if we use power rule. If we break it down the other way, we have to do a similar type of thing here. We want to make the negative 2 a positive 2 by moving this whole thing, x to the negative 4, to the denominator, but the negative 2 becomes a positive 2. Then we say that we have 2 factors of x to the negative 4, so 1 over x to the negative 4 times x to the negative 4. Now we use this formula and we add our exponents, so negative 4 plus a negative 4 is a negative 8, and we get 1 over x to the negative 8. Now if we want to get rid of our fraction, we can move this x to the negative 8 back to the numerator, but we have to change the sign on the exponent. So right now we have a negative 8, we need to make it a positive 8, so we get x to the positive 8. And notice that's the same answer we got using power rule. So that's how you use power rule to simplify expressions with negative exponents.